Good evening. Happy Friday, everybody. Yeah, I'm just pushing down this hair so that it doesn't look bad, empty up there. So yeah, I'm balding. Yeah, it's kind of embarrassing, but whatever. All right. So welcome back. Happy Friday. And yeah, I've been pretty busy. Yeah, but the week is over, so that's great. Happy Friday. Now, so how was your day? How was your week? I hope you have a very good one. And uh, so I got some feedbacks about my special relativity paper, our paper. Yeah, I mean, they're all my friends. Okay, so yeah, they give me what they think about it, right? Some of them, yeah, good job. Some others, hmm, right? They are my friends, so they are very honest with me. So they tell me what they think. So yeah, some liked it and some didn't. Okay, so yeah, but they're my friends. They're honest with me. Okay, so but I appreciate them reading, taking time to read our article. Hey, what can I ask more? What can I ask more? Right? They took the time to read this article. This special relativity disproof, and I'm grateful for their time reading it, also giving me some feedback because they're very valuable feedbacks, right? Yeah, constructive criticism. Yeah. So yeah, I'll address some of their concerns in the next paper, the disproof of general relativity. Okay, one of the concerns they expressed is that the experimental evidence that supports special or general relativities. Okay, so this is where this fourth echelon force plays a big role in this next paper. Why? Ideological force, right? So ideology, general relativityism, pro-Einsteinism. It generates huge ideological force or force wind. So people are influenced by this ideological force of Einsteinianism, or Einsteinism. Okay, yeah. But those people who are pro-Einsteinist, yeah, they have this ideologon, this unit of ideology inside of them, just like electrical charged particle or magnet, right? Yeah. So they have this ideology inside of them, Einsteinism, pro-Einsteinism. Okay, they have that. So when I say something against general relativity, uh, they don't like it. Why? Because it's different from their what they know to be true. Now, about all those experimental evidences, I think it's yeah. Some of them I'm sure lied, okay, to fit their experimental data into the Einsteinian formula. I'm sure some of them lied, but others, well, they first of all they don't know. They assume that Einstein to be true, Einstein's theory to be correct. So when the experimental result contradicts Einsteinian prediction, what do? They tweak their experiment and they experiment again and again until the data by chance fit into Einsteinian equation. So it's experimental bias, right? So because they already assumed Einstein's result to be true. Why? It's just too big. For if their experimental result contradict Einsteinian prediction, people will think that this poor unknown experimenter is wrong and Einstein is still right, right? So in order to gain some recognition, they have to experiment again in order to fit into Einsteinian prediction. Or they may fudge the data, perhaps. Right. I think that's what happened for past 100 years. That's what I think. Okay. Scientists, they are people too. Okay. Yeah. I mean, look at us. I mean, me, I'm kind of half and half. I'm half scientist and half secular. But look at the rest of us. We are the same way. When there's pro-LGBT activism, pro-BLM activism, pro-tattoo piercing activism, pro-sugar fetishism, and anti-tobaccoism, anti-alcoholism, right? Most people just don't contradict those mainstream majoritarian ideologies because it will make their lives unnecessarily stressful. Because they are, to them, it doesn't matter really. I mean, pro LGBT, anti LGBT, it doesn't matter. It doesn't affect, or does not affect their lives. So they just go along with the majoritarian mainstream view in order to make their lives easier. Okay? Yeah. So scientists, they're the same way. They're people. Okay? Yeah, they're not saints. People are people. So yeah. Yeah. It's just one table, right? There are four rows and three columns, and but there's still a lot to think about this before we start writing, because uh, yeah, we have this backbone structure, right, and framework. Now we need to flesh it. So your force and your object that is subject to the force, right, in each echelon, and you have subset, superset, superset, superduper set, right? So yeah, so upper set include lower set, the subset, superset, subset, superset. Okay. Yeah, we'll use that theory, of course, and then so we need to define what force is and what object is. I mean, that belongs to this force set. So you gotta come up with this very nice terminology. All right, set of terminologies. You have objects and the force. Objects that is affected by the force. This the member object force set or object member set force, whatever. Yeah, force set, object member, sure. Yeah, we have some ideas, we got substance now, but we need to formalize this. Probably we need another whiteboard to formally express this. Yeah, but it's not that difficult. It's a subset relationship. We're gonna define a set, each set, right? So, yeah. We need to define what is force. Well, it's a set. Then what's the criteria for each set, and what are the members that belong to that set, that kind of stuff. Yeah. And in the fourth set, there is this multiple complementary sets, constituent sets, constitutive sets. Yeah, they are disjoint with each other. So you'll be set theoretical. But set theory is very easy, so Right, we'll take 5 minutes break and then we're gonna grab another whiteboard and well, we'll think about this first, okay, and then grab another whiteboard and we'll formalize it using Venn diagram, the set theory, which is very easy. If you don't have any mathematical background, no problem, okay. Set theory is very very easy. It's about subset, superset. Uh, that's pretty much it, okay. Okay, let's take 5 minutes. Alright. Alright. Okay, so far what we know, let's just summarize. Third level and lower, we got it figured out, right? Yeah, it's just matter of third tier. You just need the physical existence that occupies some space, like photon, right? It has certain size, right? Yeah, wavelengths. Okay, and then second layer, yeah, you need physical space, but you also need mass. Okay. So okay, the second layer. First layer, you need something extra, like net non-zero electric charge or some magnetic spin or some adhesiveness, Velcro, zipper, lock and key, whatever. Something more specific, okay? Now, when it comes to ideology, we have to talk about it somewhat, okay? But I let's think about this. This is gonna take some time because it's philosophical question. What is an ideology, you know? And ideological force. What is ideological force? And does it need something extra? Yeah, it needs existence of metaphysical concept. But when it comes to human being, it does take memory space and also mass as well. Neurons, it has mass, right? Yeah, I haven't quite figured this out yet. Okay, so let's loosen up a little bit. We don't have to be mathematically rigorous yet, right? So, so what generates the force? Well, existence of electron or some net charge, proton, be it proton, electron, whatever, or some magnets, right? With mass and space occupation. And here you have just some mass, right? Some material with mass. Here you have photon. Then but in order to generate ethereal wind, well, in our framework, ethereal wind means accelerative force, right? It's an analogy, okay? So, and gravitational force, you need some kind of mass, right? And pushing force, engine, motor, wind, yeah, it requires mass, and yeah, okay, yeah. So ideology, let's just give it a narrative, right? For ideological force, it's like this, all right? So there is this Einsteinism, his general relativity or special relativity, right? It's a big ideological force. So scientists, they want to conform. It's like scientists are like these compasses, individual compasses. And when there's strong magnetic field, the direction of compass align itself along this magnetic field lines, right? Yeah, it's just elementary school physics experiment, right? Yeah. You have two big magnets, right? So you re-angle the two big magnets. In the middle, you have small magnets like compasses, right? So as you move along the big magnets, small compasses they go along this magnetic field line, right? Yeah, they reorient themselves. Why? Because they're small guys. Big magnets, big guys. Just like in politics, right? You have big, gigantic figure like President Trump or Vice President Joe Biden, right? So whatever they say, yeah, if I'm Republican, yeah, let's go along with President Trump because he's a big guy, I'm a very small guy, right? Because, but yeah, of course, I'm at least in my mind, I'm not that small, so I have to challenge his ideas. But or Democratic Party, they go along with the party line. Even Vice President Joe Biden go along the party line. Democratic Party, which is bigger than he, right? He just obey. Yeah, pro-LGBT, anti-abortion, and pro-abortion, anti-gun, pro-immigrant, pro-marijuana. That's Democratic Party, right? Of course, those party lines change over time, though. I mean, ideolo- ideology. That's a big topic in humanology, but here, study of ideology is very small part, more, almost like fringe part, kind of like addendum, not very central. Okay, it's a very fringe part of this physics paper about disproving general relativity. So I need to limit the quantity of discussion for about ideological force, though, or maybe I can tell some more, but because this can go very long time. Study of ideology, there's a big subject on its own. So I'm not sure how much I should talk about this ideology in this physics paper. I mean, there's no deadline for this paper because something I do as a hobby. So we do as a hobby. So, but I don't want to elongate this paper way too long. 50-page max, maybe 50 some pages. So, a concept, okay, ideologon, right? That was subject to this ideological force, right? And this concept doesn't have to have some physical space to exist, right? Like an apple, right? Concept of an apple. Yeah, we can write down APPLE on a piece of paper. Or we can type in and store in magnetic hard disk drive or memory drive, which is electronic, right? I mean, memory in computer. Or we can think about apple on our head using our neurons, right? Or an apple can actually exist in physical form on our kitchen table, whatever, right? But the concept of apple does not depend on this physical existence of an apple or in a medium, like pencil and paper, right? The concept of apple, its existence, is metaphysical. So it does not depend on physical space or existence, the concept of an apple. Okay, so that's why it's kind of philosophical, kind of ontology, epistemology, kind of like even existentialism. Probably I'll just leave it at that. Okay, yeah, and details of ideology, yeah, you have to be another paper in philosophy, in metaphysics. So yeah. But we need to introduce this in order to explain the phenomenon why, for 100 years, all these experimental scientists verified Einsteinian special and general relativity theories, although it's obviously so easily wrong theories. It wasn't difficult for us to disprove both special and general relativity because the errors that Mr. Einstein made is something very easy and obvious errors. They're not very difficult technical errors. Okay, they're very conceptual, elementary errors that he made. Okay, so Mr. Einstein, he's like, we'll take 5 minutes break. Okay, so then we make some jokes. Okay, I some vocal rest. So okay. Okay, we're back. So I was taking a cigarette break and I realized something that, it kind of explains the difficulty that I was having. Yeah, I don't think metaphysics can be defined mathematically. Why? I'll tell you why. Because between sciences or philosophy or any academic branches, there is hierarchy, right? So the lowest bottom in physical science, uh, you have biology, okay? Above that, you have chemistry. Above that, you have physics. Above that, you have mathematics. Above that, you have metaphysics, like philosophy, okay? So, yeah, so the upper echelon cannot be defined by some methodology that belongs to the lower echelon. Yeah. Okay. Good. Very good. This is fun stuff, okay? Yeah. It's good that we are taking time writing this article, right? Because it's a work in progress. I'm not ready to write this. There's more to discover here. It will be a physics paper, but at the same time, it will be metaphysics paper. It's like there's no other way around it. We have to do both. The length of this paper may exceed 50 pages. Possibly. Yeah. It will take time. It will take time. So, ideological force, it can move things around, all right? It can build rocket engine and that accelerates. Okay, or ideological force can build a car or purchase a car with money, and then this car accelerates, and the passenger there experience the ethereal wind, right? Yeah. Yeah, ideological force like Democratic Party can move around these computers that have magnets inside. The hard disk drive that's magnetic, okay, or some electric charge around. In computer memory, yeah, that's based on electron, right? Battery powered. Yeah, they can. Democratic Party convention, you can move these computers around, right? And they can accelerate with a car, airplane, right? Or Democratic Party convention can cause this some mass, like chair or table move around this convention center or whatever. Okay. But ideological force, can it move the concepts around? Well, concept is metaphysical concept. Concept is a metaphysical entity. It does not require any space to exist. What does it require to exist metaphysically? Definition. Does ideology change the definition of a concept? Yes, all the time, right? Back in the days, the concept of marriage was about man and woman, right? Nowadays, it's not. Well, according to Democratic Party's ideology, neoliberalism. Yeah, two men can marry. Two women can marry. The Democratic Party's ideology, liberalism, also changed the concept, definition of what gender is. It's no longer binary, right? According to Democratic Party people, liberalists, neo-liberalists, yeah, gender is fluid concept to them. They changed the definition. Yeah, they did change the concept around, and it happens all the time. Interesting, right? Yeah. We are doing metaphysics. No, we are more than physicists. No, we are metaphysicists. No, we are philosophers, you know. So, Mr. Einstein, he's kind of sorcerer, right? I wouldn't say Mr. Einstein is great scientist. I would say he's great sorcerer. But, yes and no, because he also fooled himself. He didn't know he was wrong. And all these experimental physicists supporting his theory, Einsteinian theory, they didn't know what was right, what was wrong. They just did assume that Mr. Einstein's equation is correct, and so they thought their experimental results were wrong, so they kept on experimenting until the result conforms to Einsteinian theory, his equation, right? Just like you roll the dice, right? Mr. Einstein predicted that this dice is weighted, is unfair dice, so it will show up 5. That was his prediction. So experimenters, they roll the dice and come up 1, then 3, 2, 6, 4, 5. If they try this rolling the dice again and again and again, they will finally get 5. They will say, bingo, yeah, I got the result right now, so I'm going to publish it. I think that's what happened, okay? So Mr. Einstein famously said, what, God does not roll the dice? Maybe he doesn't. I don't know. We don't know. But do physics experimenters roll the dice? I think they do. Okay? I think they roll the dice again and again, experiment again and again, until the result conforms to Einstein's prediction. Okay? I think that's what's been happening for more than 100 years by now. Okay, yeah. When it's 5, 5, right? It's like, oh, jackpot, right? So physicists, they have him like gamblers, okay? So this paper is gonna be very, very entertaining. Alright, I can tell. It'll be hilarious. Boy. I don't know, maybe I should start writing tomorrow, okay? Yeah, the details I can figure them out as I type in the computer, okay? Yeah, because I don't want to wait too long. I want to start writing until we still have this fresh excitement of brand new discovery. Right? Because after a while, it will go away. This fresh excitement from brand new discovery, right? Better write it down when the excitement and memory is still fresh, right? In our heads. Okay. So, what's this scientific hierarchy? Is this, biology? Between chemistry and biology, you have biochemistry, right? Yeah, also biology, what's happened between cells, yeah, it obeys also physics too. Electric force, this partially charged branches of these biomolecules, okay? This. Not exactly ion. Yeah, there are some ions in biology, like you have calcium ion and you potassium ion, neuron, whatever, right? Yeah, you have this chloride ion, whatever, right? Sodium ion. Yeah, they have that, but when it comes to proteins, it's more like slightly partial charge, like 0.3 negative charge. Okay, that's what determines this protein folding and interaction between proteins. Like slightly positive charge here and slightly negative charge here, they bind. Protein binding. Okay. Yeah. So yeah. And above biology, chemistry, physics, yeah, you have mathematics. Right? Above mathematics, you have metaphysics. So metaphysics cannot be defined by mathematics or physics or anything below. Okay, because it's a higher echelon entity. All right, we'll take 5 minutes break. Okay, so yeah, we are making progress. Happy Friday, everybody. We've been very productive and fruitful in this Friday. It is chilly. Okay. Okay, so how about social science? Yeah, it came came to me. I mean, ideas came to me when I was taking cigarette breaks. So yeah, I do have ideologon of this alcohol, tobacco in me. Okay, so because I grew up in South Korea. Okay, so yeah, I mean, I started smoking cigarette when I was in America when I was like 21. Well, before that, when I was like 19, I guess, I just smoked cigarette once or twice. Yeah, I started smoking when I was 21 in Madison, Wisconsin. Okay, I learned it from my friends in a bar. I kind of learned again, but I didn't really start smoking. Yeah, first time I smoked cigarette is like when I was like 19, 18. Okay, it was legal age to smoke cigarettes. That's how it is, how it was in Korea back then. Okay. All right, social science. Okay. Uh, well, we give some love to psychology. Okay, so yeah. Below that, you let's say you have psychology. Okay, psy, and below that maybe you have sociology, also political science, right? How about economics? I guess economics about is same rank as psychology. Okay, so yeah. What does this mean? Okay, so that's uh, biological phenomenon can be explained and analyzed by chemistry. Any phenomenon in chemistry can be explained by physics, and anything in physics can be explained by mathematics, and so on. It's kind of like that. Okay, so yeah, it's just sketch work. It may not be complete yet, but that's the idea. Yeah, so psychology, let's say psychology is about one person's behaviorism, right? Yeah, it can be explained by biology, biological desire, right? Yeah, it's not a complete picture yet. Okay. Yeah. How about social behavior, groups of people, sociology, or political science? Okay. Yeah, groups of people are composed of individual people, right? So yeah, so it can be explained by psychology or economics. Again, it's not a complete picture yet. It's not pitch perfect. It's not accurate yet, but at least we asked the right question. Maybe the answer is not correct yet. That's fine. We made the next step, right? Out of nothingness, we start with a question. Maybe our answer is not correct yet, but we leave it to the future generation. Okay, so no problem. Let them figure this out. Okay, so we made enough contribution. We don't have to do everything, right? Yeah. Sometimes we just ask a question and make suggested answer and let future generation refine the answer or whatever. Or let them come up with something completely new. Overthrow this answer, sure, if they are correct. Yeah, I have no problem with that. Yeah. Because that's kind of what we are doing, right? Mr. Einstein asked the right question, but he didn't get the answer right. So we are overthrowing his answers, but we are answering his questions, though. Right? Yeah. Mr. Einstein, yeah, probably he'll be very proud of us, okay? So we are correcting his errors, right? I don't think he would resent us. At the end of the day, he was a minority, okay? When he came up with his theories, of course, we know by now they are wrong theories, but yeah, he was not a great scientist, okay? He made great mistake, great errors, so he's not a great scientist. He did not do so intentionally, so he's not like so thorough, like because he didn't know he was wrong. It's not like he intentionally deceived people like a sorcerer would. He didn't do that. It was not more like blind leading the blind kind of situation, right? All these thousands and millions of scientists all around the world over 100 years, blind leading the blind. Okay, there's at the front of this throngs, crowd of people, physicists. On the very forefront, there's Mr. Einstein. Yeah. And where they are going, to black hole, like cliff. It's like lemming, army of lemmings, lunging toward black hole. I'm sure that's pretty a lot worse than cliff, don't you think? Maybe I'll write about that. Okay. Oh my goodness, this paper is gonna be really funny. So we are trying to save them. And not physically, they're not physically dying or anything, but they are wasting a lot of taxpayers' money looking for a black hole that doesn't even exist. E equal mc squared, yeah, that such equation doesn't exist. Okay, it's just wrong equations. We should put a stop on this waste of taxpayers' money all around the world, funding these wrong projects, studying wrong theories. That's waste of people's money and time. I mean, Vice President Joe Biden, he suggested that all these buildings and houses are so environmentally unsound, so he's going to destroy all of them and build brand new buildings, houses. I said that's waste of money and time and people's labor. And if people's labor and capital and time, effort is wasted on useless projects like that, then people's money and time and labor cannot be spent on something very essential and necessary. Why? There's so much time, there are so much people, so many people, there's so much capital. So it's opportunity concept, opportunity cost concept in economics, right? Yeah, one person can only do one thing at a time, and if this person is destroying the fine, well-functioning buildings and houses, if they're destroying them, demolishing them, and build a brand new one, what about some other essential services? This person is wasting his time destroying our building and rebuilding that building with some more environmentally sound. Huh? So this person is wasting his time when he was otherwise he would spend his time and the capital doing something more useful, essential business. Okay, so Vice President Joe Biden, he does not understand economics. Okay, so opportunity cost concept is very basic concept in economics. Okay, he doesn't understand. Okay. Yeah. We'll take 5 to 10 minutes break, okay, and then we'll put this whiteboard behind us because we achieved a lot today, okay? So, and we'll talk about something else. Okay? Yeah. We're done with science for tonight, okay? We did enough, alright? So we'll keep pace and alright, see you soon.